Hi, welcome to Algebra 2 Common Core. Today we're going to watch the first of many videos that we will be viewing for this course. In this lesson we're going to talk about multiplication of polynomials, but we're going to start with a review of definitions and properties that we're going to need throughout this year. Let's start with the definition of a variable. A variable is a quantity that is represented by a letter or symbol that is unknown or can change within the context of the problem. Take a few minutes and write down that definition. Some examples of variables would be: we very often see the variables x or y within problems, but we're also going to see variables such as r for radius. We might see something that looks like a z sometimes in a problem. Variables can be any letter. Very often, though, it's going to be a lowercase letter of the alphabet. Our next definition is a term. Terms represent a single number or combination of numbers and variables. So, for example, we might have something like 5x. That's a product of a number and a variable. We might have something like negative 2y squared. Again, the product of the number negative 2 with the variable y squared. We can also have a combination of variables. So, for example, we could have 12ab squared c to the third, and that represents a term. Anytime numbers and variables are combined with multiplication, the quantity stands for a whole term. We would have an expression when we have a combination of terms using addition and/or subtraction. So let's take a look at a few examples of expressions. If I have the expression 2x plus 3y. That would be an expression because I've combined the term 2x and the term 3y with addition. You'll notice that that expression has two terms, so we call it a binomial. We could also have an expression that looks like the following: 4x squared minus 8x plus 6. That's an expression that combines the terms 4x squared, 8x, and 6 using both addition and subtraction. So we can count these terms and say that there are 3 terms in this expression, so that would make this expression a trinomial. So anytime we have a combination of terms using addition and/or subtraction, that stands for an expression. Like terms are when we have 2 or more terms that have the same variables raised to the same powers. So, for example, we will have like terms if we have something like 3x squared and negative 7x squared. You'll notice that the variables match exactly. They're both x and they both have a power of 2. What doesn't have to match are the coefficients. So I've got a 3 and a negative 7. When we have like terms, we are allowed to add like terms together. So if I had the problem 3x squared minus 7x squared, I can combine these like terms to get negative 4x squared, just by adding the coefficients. Next, we're going to take a look at the properties of real numbers. The first property of real numbers that we're going to look at is the commutative property. The commutative property applies to both the operations of addition and to multiplication. So if I have an addition problem, the commutative property says that I can add two numbers in either order. For example, if I've got something like 3x plus 5x, it's exactly the same thing as adding 5x plus 3x. So the commutative property of addition says that addition can be done in either order and the results will be exactly the same. The commutative property also applies to multiplication. So if, for example, I've got x multiplied by y, I could say it's exactly the same product as y multiplied by x. So multiplication can also be done in either order. Take a look at an example, an easy example with numbers. So for example, if I know that I'm multiplying -2 times 6, I get exactly the same answer if I multiply 6 times -2. So that's the commutative property of multiplication. You'll notice that the commutative property does not apply to either subtraction or division. Order is really important in those two operations. Our next property that we'll look at is called the associative property. The associative property has to do with grouping, and I'm even going to fill that in so that I remember that it has to do with how I'm grouping when I'm doing addition and multiplication. So for example, when I'm adding together 2x plus 3x plus 4x, I can either group together the 2x and the 3x and then add on the 4x, or I could group it in a different manner by grouping together the 3x and the 4x first and then adding on the 2x. You'll notice that in either case I'm going to get exactly the same sum on the left side and the right side of 9x. So the associative property says that I can group with addition in any order that I want, and I'm going to show that grouping using multiplication. Using parentheses. The next property, the associative property of multiplication, also deals with grouping. So when I am multiplying, I can multiply A times B times C, or I can multiply A times B first and then multiply that product by C. Again, think about this in the case of a number, and I'm sure it'll make a lot of sense to you. If I'm going to multiply 2 times 4 times 3, I can multiply the 2 times the 4 first and get 8. 8 times 3 gives me 24. Or I could say, let's multiply 2 times the product that I get when I first multiply 4 times 3. So 4 times 3, of course, is 12. 2 times 12 also gives me 24. So the associative property applies to both addition and to multiplication. The last property of real numbers is called the distributive property, and I'm sure we are all very familiar with the distributive property from other algebra classes. In the general form, the distributive property says if I've got a term C and I'm multiplying by a sum A plus B, I'm going to distribute the C times the A, so I'm going to multiply C times A, and then I'm going to distribute the C times the B. So I'm going to get exactly the same result if I take the C and I multiply it by each of the terms inside the parentheses. We'll see the distributive property in the following kind of situation. Let's say that I'm multiplying -2 times 5x minus 3y. And yes, I'm hoping this is really easy for you. This should be something that you know already. -2 times 5x will get multiplied together. And then I'm going to multiply together -2 times 3y. And when I do that, I see that I get -10x minus 6y for my final answer, using the distributive property. Now that we have reviewed our basic definitions and our real number properties, let's use all of these in exercise number 1. Exercise number 1 should be a review of something that you learned how to do back in Algebra Common Core. I know it's been 2 years, so we're going to review it right now and do this example together. Exercise number 1 says simplify the given expression and state the real number property that justifies each step. In Common Core classes, it's going to be really important for us to do justification. So that's why I'm highlighting that. We have to justify using our steps. So we're going to have to tell which property we used in order to do each step. Let's go ahead and do the first step. So I look at this and I say 8 multiplied by 2x plus 3 plus 5 multiplied by 3x plus 1. We all know that our first step, and I'm even going to label them 1, 2, 3. So I'm going to say the first step is going to be to use the distributive property. So we're going to say 8 is going to be multiplied by 2x, and also 8 is going to be multiplied by 3. I'm also going to distribute using the 5, so 5 is going to be multiplied by 3x, and 5 is going to be multiplied by 1. I'm going to write down what we used, so we used the distributive property here. That's our justification for that first step. Now, in my second step, what I notice is that I've got several terms that have x's. So I'm going to say, let's group together the 8 times the 2 and say, multiplying 8 times 2 times x, I'm going to actually multiply 8 times 2 first of all, and then multiply by x. 8 times 3 will multiply together, and that's just going to give me a 24. But then in my distribution of 5 times 3x, I'm going to multiply 5 times 3 and multiply that product by x. 5 times 1 is just 5. What I've really done here, if you pay attention, was that I did some grouping. I grouped together the 8 times the 2 that was in front of the x and the 5 times 3 that was in front of the x, the coefficients. Anytime I'm talking about grouping, I am talking about the associative property. So my justification for this step would be the associative property. Now I want to be very specific because I've actually used the associative property of multiplication. So I'm going to write that down. I'm not going to just call it the associative property. I'm going to tell which associative property I've used. Now that allows us to then go ahead and do that multiplication. So right now I have 16x plus 24 plus 15x plus 5. So in that case, I haven't really used a product. I just did the associative property there. Now the next thing that I'm going to do is notice that I have like terms. So when I have like terms, I want to be able to group them together. That tells me that I want to rearrange the order. So looking at this pair right here, if I rearrange the order of these two terms, then my x's will be next to each other and my constants will be next to each other. So I'm going to rewrite this as 16x plus 15x plus 24 plus 5. The justification there, when I rearranged the order, that used the commutative property. So let's write down our justification. Now think about which commutative property that is. Because I've got addition going on here, I'm going to say this was the commutative property of addition. So I was allowed to rearrange the order of the terms as they were written down because they were being added together. Now I'm going to do some more grouping here. So I'm going to say, okay, the grouping is going to be group together those two, group together those two. So when I group together 16x and 15x, and I group together the 24 and the 5, the justification there is the associative property. And that, of course, is now the associative property of addition this time because I've grouped together addition terms. Let's go ahead and do that addition. So to finish up this problem, I'm getting 31x plus 29. So that's just real number addition. Okay, so I'm just going to call that addition right there. So for each step that we performed in simplifying this expression from the beginning, we had to justify the step using the real number property that we were applying. Thanks for reviewing our beginning algebra terms and definitions, as well as the real number properties. Have a good day, and we'll see you next time.